Hi and welcome to the simplest guide to using blue-green deployments in Kubernetes. Our speaker today is Dan Garfield. He's our chief evangelist from Codefresh, and I'll let him go ahead and introduce himself and start the webinar.
My name is Dan Garfield. Like Karen said, I'm the chief evangelist at Codefresh. I do a lot of our go-to-market stuff, but I'm also a full-stack engineer and Kubernetes, and have been building Kubernetes apps for probably over a year and a half now, and I've spoken at KubeCon and been heavily involved with the community, both from Kubernetes and Helm and Iste, and work with a lot of those open source projects on kind of how we can push them forward and things. But anyway, you can find me on Twitter. Today was awesome. Feel free to hit up at Codefresh as well if you have questions after this, or if you want to collaborate on anything. Happy to do that. Just by way of introduction, Codefresh is a CI/CD platform designed specifically for Kubernetes and specifically for containers, and so it's got a lot of sort of built-in tooling to help you build, test, and deploy your Kubernetes applications. But today we're going to be talking about blue-green deployment, and this is going to be the simplest way to do blue-green deployment by yourself today. Hopefully you get a lot of it. So the question is, what is blue-green deployment, just to start off? Blue-green deployment is basically you have a version of your application that we're going to call a blue version. This is production version. And that's what users are currently seeing. And you roll out the green version, which is the new version, and then you switch everything over to the green version, and then maybe you get rid of the blue version. You don't have to get rid of the blue version. You might want to keep it around as a hot swap. And just to, I want to kill the screen share here for a second, just so we can talk about it. But basically, like, if you think about it, this is actually the first way that I learned how to deploy software. So when I got started years ago, what we would do is we would have two servers, and one, the load balancer would be pushing traffic to one, and then I would FTP or SSH into the second server, push my changes, say, hey, that probably looks good, switch the load balancer over to that one. If there were any issues, I'd switch back. Otherwise, it would switch there. And that was blue-green, right? It's everybody gets one version of the application at a time, and when you're ready to switch, everything switches over. So I've got some handy visual aids here. When it comes to Kubernetes, of course, we're dealing with containers, and I didn't have a green container, so it's blue-orange deployment. But basically what's going to happen is you've got your blue version that's in production, and this is what users are seeing. We're going to introduce the green version. This is green, so it's part of the guide. This is green. You introduce your green version, and your user is still only getting the blue version. And when you're ready, you make a switch so that they get the green version. And then it's optional if you want to remove the blue version or if you want to keep it around as a hot swap that you can fall back on. So goes down, and I'm going to animate this because one of the questions I got, we've done if you haven't seen, we did Canary deployment guide using Iste, which is quite a bit more advanced and kind of the direction that I advise people to go in. But as you just get into Kubernetes, and Iste is still relatively new, there aren't that many people using it in production yet. But with Kubernetes, I got questions about different deployment strategies because it can get confusing about how your deployments work, and there's some nuances between different deployment strategies that make it difficult. So if you're doing a default Kubernetes deployment, you're doing a rolling update. And a rolling update is a little bit different. I'm going to show you this animation here that I think will help explain it. So when you do a rolling update, you basically introduce the new version of your application and remove the old version of your application at the pod level. And so to reiterate that, let's say right here we've got 1, 2, 3, 4, 5, 6, 7. We've got 7 pods, so to speak, of our blue version. we issue a rolling update, and what's going to happen is as the new pods come online, it will remove the old one that it's replacing, and your end user could be getting the blue version or the green version. We don't know, right? They're just going to get one randomly assigned by the load balancer until the rolling update is complete. So there are lots of situations where you don't want to have that happen, and it puts you in a position where you don't have a hot swap available. If there are any issues, you can't roll back, so you can't do like a post-deploy health check and then just say, oh, switch back to the old one because I don't want to use it. So the rolling update is fine for a lot of people, but it's also not, I would say it's not, it's not as controlled. You don't have nearly as much control. Just a note, here's an anecdote for you. I was at a conference yesterday, and I was talking to an ops team about how people deploy. And this is brilliant, I love this. They said, we have somebody who was deploying, and the way that they did it is they used a single, the master tag on their image, or they used the latest tag on their image, and they set their pod on restart to always pull the image instead of just using what's cached. And so the way that they decided to do their deployments was they would just delete all their pods, which would cause them to respawn and re-pull the image. And I thought that's a really creative way to do a deployment. It's also terrible because it means you have no ability to roll back. And it also means that you interrupt services because you destroy. I'm getting a comment that there's lots of echo and the audio is hard to follow. Let me see if I can fix that really quick. Hang on. Let's try it this way.
All right, is that a little bit better?
That's much better, Dan. Thank you.
Okay, all right. Sorry about that. Okay, so what I was just saying was that this engineer had implemented what was basically a really awful. I'll just switch video here to make it less confusing. This engineer had essentially engineered their own way to do the deployment that was just deleting the pods and having it re-pull the latest branch. But the problem with that is that you can't do a rollback. So if there's anything wrong, you're just stuck and you need to rebuild, re-push an image. And it's also, it also causes service interruption, right? For you to go just delete pods and delete all your pods and then have them re-pull. So I don't recommend that. You need to have a structured way of doing it, right? So let's jump back over to the presentation here. All right, so that's a rolling update versus a blue-green. So here's what blue-green looks like. In blue-green, you have your pod set. You've got 7 pods or whatever. And what you do is you replicate what currently exists. That's your green version. And you introduce all of that at once. Now, at this point, the user is not getting any of that green traffic, right? They're only seeing the blue version. And once the green version is fully ready, fully deployed, then you switch them over so that they only see the green version. So from a user perspective, a blue-green update is sort of more consistent. And there's sort of less chance for people to be getting different versions of your application at the same time, because the end user is only ever seeing one version of the application. So to reiterate that again, you start with your blue version, you introduce your green version, and that green version could take a few minutes to spin up, right? But once it's ready, then you switch things over and the user only gets the green version. All of your users get the green version. Now, one little just thing I want to mention, when you're doing a rolling update, and when you're doing a blue-green update, you do need to use, in Kubernetes, there's this entity called a readiness check. And what a readiness check does is it lets you define basically a metric that says, okay, this application is ready. And why do you need that? Well, if you think about what Kubernetes is actually doing when you're spinning up a pod, the first thing it does is it creates a pod and it creates a container. And it will say that it's ready when it's ready to start running code. But what if the thing inside your container takes a few minutes to start up, right? So maybe it's your .NET server. Your container starts and it takes a minute to start up and actually start listening on ports. That means this container is marked as ready, but it's not actually capable of serving traffic at this point. And that means that if you launch it without a readiness probe, without some kind of health check, then users are going to get sent to containers that are ready that aren't serving anything. So you don't want to do that. What you want to use a readiness check because that will let you accurately decide that a pod is actually ready. And then when you're doing a blue-green, you can actually mitigate further, right, by saying, I want the entire deployment set to be ready. Now, coming back and thinking about the scale here for a second, if you've got one container, then the only way to do blue-green is with one other container, right? And you're basically matching the scale of your rollout, right? So you had one, and now you have one. That's fine. Now, if you have 100 containers, right? You've got 100 pods. Then you want to match that scale again too. And when you're doing a rollout, a regular rollout like the ones we were talking about, if you only have 1 and 1, then a rollout with a readiness check is basically identical to a blue-green deployment. Once you have more than one container is when it becomes different. Because that's where you get into having people mixed traffic, right? So let's jump back over. I'm going to share my screen again, and we'll look at the implication with Kubernetes. So with Kubernetes, we're going to introduce a couple of elements here. Now, the way that Kubernetes works is you have a deployment, which is where your pods live, and you can specify in your load balancer, which in Kubernetes is our service, you can specify which deployment is going to get the traffic. And so here, it's just like our blue-green version, except we're replacing it with containers. And we can actually specify that inside of our service and our deployment. And I'll show you what I mean. If I throw open some terminal here, I've got an application here called Demo Chat. This is what it looks like. It is a simple chat application. It's basically just a Node.js app and a MongoDB. So here you can see it says, let's chat blue 5. And we're going to change it to probably just say green here in a minute. But to come back over and let's look at just what's going on with this service right now. If I do a kubectl get service, in the namespace that I have set up here, which is blue-green, you'll see I have my demo chat service, which is acting as a load balancer for my deployment. And if I do it, if I output the YAML here, so we can actually look at what it's specifying, you'll see that basically what it's saying, when it comes to the deployment it's going to work with, it's saying, I want to find the deployment that's named demo chat that is this version. So this is my current running production blue version of my application. And if we look at that, so now we look at the deployments that are associated with this, we'll see that there's currently one deployment running. And it's named demo chat-9ddbba7. I like to use my commit SHAs from Git as all of my versioning. A lot of people like to use like V1, V2, V3, and they'll bump that version every time. I don't like that convention. I like to use my commit SHA because it means it's more GitOpsy, right? It means that my commit, Git repo will always tell me what's currently in production, and I can always match up those two IDs, and they're unique. And it also means that if I want to do a rollback, I can just do it in Git. I can just Git revert back to a previous version that will create the commit that will then go out and roll things back to the previous version that I already had. We'll need to rebuild the image, for example. So if we look at this descriptor, Git deployment, output is YAML, and namespace green. What you'll see is that in here, I have defined labels on this thing that say that the name is demo chat and the version is this version. So what we're going to do here when we do the blue green is we're going to take this whole deployment, and we're going to replicate it and just change all of the versions, all of these IDs to be my new commit shot. Because you can see that my image that it's pulling is based on the commit shot here. And you could have a branch name on there too if you wanted. I do like to use a branch plus a commit shot. I just want to keep it simple for today. But all of these versions that are in here, we can just override with our new commit shot. And you can see I've got two replicas, right? So, because otherwise a rolling update would be identical. And here you can see I've got my currently running pods. So you can see there's two versions, sorry, not two versions. There are two pods currently running, serving my blue version of my application. And if we look at my application, we can see that it is running. Everything is good to go here. Now, what we're gonna do next is let's do this. I'm going to fire off a commit. Let's make a change to this application. And we're going to let it automatically run this blue-green deployment. So I'm just going to edit this headline that says blue 5, and we're going to say green. So right here where it says let's chat blue 5, we're going to change that so it says green. So let's exit there. And what this will do is once I push this, we'll see that inside of Codefresh, it's going to kick off a build. There it goes for this new release. And as I mentioned at the very beginning, Codefresh is a CI/CD platform designed for Kubernetes and Helm, and we have all kinds of tools to help you interact with Kubernetes. We really have the best Kubernetes integration I'm going to say in the world, in all of the universe. We really make it a first-class citizen. So you can see over here while it's building, I've got my Kubernetes cluster. I have a number of clusters here. The one that we're working with is in this namespace. You can see the endpoint. That's the application that we were looking at. It's still on blue 5. It's rolling out. And I can see the image that's currently running. I can actually manipulate these manifests, and then I have built-in steps for deploying to Kubernetes. So let's jump back over here and look at this build because right now it's performing the blue-green deployment. Oh, actually it's complete. So that whole pipeline, it built the image in about 24 seconds and then performed the blue-green deployment. So we actually missed it over here. You can see these are now 28 seconds old. What it did is it moved a little too fast for me. So if we go and look at this, we'll see that it's the green version, right? So let's look at it again from the pod perspective. Let's just make another little change. And then we'll talk about how this is actually functioning, what it's actually doing. So we're gonna go back to blue. Go back to blue, and we're going to push that. So this will kick off another build in half a second here. There it goes. Now this time we're going to watch the pods here, and what you'll see is that the new deployment will be created, and there's going to be this line here that says waiting for rollout to complete. That once it's done, will actually switch the service over. So we'll go into the kind of details and the things that are happening here. So now it's going into the deployment. It built the image successfully. And now you can see that this rollout has started. These 2 new pods are being created. It's waiting for the rollout to finish. 0 of 2 updated replicas available. These containers are creating. 1 is already ready, which the UI got before the terminal did. And then we're waiting for the second one to create. It's now set, and then it finishes the rollout, and there's this mark that says the service for demo chat was configured, which means it's now pointing to the new version. And again, if we come back and reload this, we'll see that it will say let's chat blue. So we've got a blue-green going here, right? Now, I have elected in my pipeline to kill the hot swap and delete the old version. You don't have to do that, right? It's just really a question of timing, right? So what you might want to do is leave a hot swap available around for 30 minutes and then delete it. Or you might want to leave it around indefinitely. It really just depends on how many pods you're dealing with to make it economical. Because if you've got, 45 nodes worth of pods, then keeping a hot swap means you're going to have 90 nodes worth of pods. So you're going to double your cost for your cluster. So it's really just a question of what you want to do. And I think of a hot swap as always matching the number of replicas, because if it doesn't, it can't handle the scale that exists. Now, the way that this works is it goes through a couple of steps. And this just to step back for a sec, this webinar is called The Simplest Guide to Blue-Green Deployment, because it's really about how do you create your own blue-green deployments from scratch. We have a blue-green deployment step that we're working on and have been testing internally that is just sort of a one-click drop-in solution, similar to what we did in our Canary releases with Codefresh using Istio. So there's kind of some, you can work around, you don't have to do this much technical stuff just to get a blue-green deployment working. We will provide the sort of kind of built-in step way to do it. But let's look at actually how the what's actually happening here. And I've left the scripts basically naked so you can see all of the steps and we can look through them. So we can explain what's going on. So let's share the screen again and we'll come back into it. So what's actually going on here, let's go into here. Look at our build. Let's look at the pipeline that I defined here. So here's the pipeline that I set up in Codefresh. You can see that I am associated with my repository that I'm editing, this demo chat repository. I've got a couple of pipelines here. We're working in the blue-green one, and it's set up with a trigger so that anytime I make a change, it triggers this blue-green rollout. This demo chat one is filtered for a specific branch. You can filter for tags or for pull requests or any of those kinds of things. You can actually trigger based on cron jobs or even images being pushed. So there are a lot of options there. Now I could keep my pipeline configuration inside of my repository. I've elected to use inline YAML editing so that it's just easy to look at. And we're going to step through what this does. So the first step here is it's going to build the Docker image, right? And it's going to give it a name, and it's going to use the Docker file that's in the repository to build it, and it's going to tag it with the commit shop, which is this variable here, CF short revision. And when we build this Docker image, what you'll actually have seen is in the builds flow, when we ran this build, it only took 19 seconds. Why? Because most of the layers in that image already existed, and it only had to modify one layer and then push it. So we've spent a few thousand hours optimizing how we build Docker images so that we can build them as fast as possible. So that's just how that build step is going to happen. Next, we get into this blue-green deploy step. And what I actually do is I pull the Codefresh Kubernetes Helm master image, which has all the tooling for working with Kubernetes and Helm. Again, this is going to be more complex looking than like the built-in version of these steps, where you do a blue, green, or a canary rollout using sort of our built-in deploy scripts. But I wanted to leave it again sort of naked here so you could see what it's actually going to do. So the first thing it's going to do, it's going to tell it which Kubernetes context to use, and that is our Helm demo at JFrog Helm. Where is this defined? Well, I go over to Kubernetes and I added a cluster, and it was named Helm demo at JFrog Helm. So if I wanted to add another cluster, you know, if I'm using GKE, I can actually just browse my projects and add clusters straight from there, and then they're available inside of my my account to deploy to. And you can set role-based access controls on those things. All right, so that's where I define what cluster I'm going to work with, and I define the namespace I'm going to work with. So I say this is the name, this is the Kubernetes configuration I want to use, and then what I do is I export a variable called blue version, which is to get what version is currently running. So to do that, I run a command that's Coop control get service demo chat, output the JSON, and look for this specific path to find out what the version is that's currently running. And now once I have that, I can basically just do a find and replace in my deployment. So to show that visually, there's a whole blog post guide on how to do this at our blog that's called The Simplest Guide to Using Blue-Green Deployment in Kubernetes. We published it last April. So you're welcome to cruise through this, and you'll get all of this information that I'm talking about in blog post form. But what it will do is it will take the deployment and it will replace all of the instances of the old version tag with the new version tag. And then it will deploy it to Kubernetes. And when it does, it creates a second deployment instance, right? It creates a second deployment. So that puts it, basically means that if I'm using like auto scaling, and this has auto scaled up to 50 replicas, it will copy that auto scale variable and say, oh, it's at 50 right now, so that's where we're going to set the new one. So that way you know, it's sort of like a clutch on a car. It's like blended, right? So you're getting the exact number, the exact scale that you want to do. And then the next thing that we're going to do once we run that, and here you can see we're basically in this script just using sed to replace the blue version with our green version, which is our new commit shop, and then applying it. What it's going to do is issue a health check. And in this case, I'm just using Coop control rollout status to see if the deployment has finished rolling out yet. Now, again, you want to pair that with a readiness check because otherwise it will say that it's ready, but it may not actually be serving traffic, right? So this will do a rollout status check, and once that, and this step will wait, and we saw that, right? In our build logs here, when we looked at it, it actually showed the, hey, waiting for this rollout to be finished, 0 of 2 is done, 1 of 2 is done, and then deployment has successfully rolled out. And then it was ready to move on to the next step. So once that next step is going to be setting the service. And if you remember at the very beginning, I did this, I don't think outputted is a word. I echoed out, I guess, the service YAML. And remember what we saw was that there was a selector in here that said, this is the deployment I want to use, the one that is named demo chat and has this version. So what we're going to do is we're just going to update this, this version to point at the new deployment. And so that's going to happen here with this step that says get service, output the whole thing as YAML, then do a sed to replace the blue version with the green version, and then apply that, and it will update the service YAML. And now once that's done, the rollout is finished, and optionally we have this step here to delete the deployment. We could add conditionals on that If we wanted to, we could separate it out into a separate step. And then if that rolls out successfully, it writes metadata onto the image to say that it was deployed to production. So if I'm looking at my builds, I can see the images associated with it. And this is the one that I built, this Containers 101 demo chat. And if I open it, we'll see that it does have this annotation that says deployed to production. Now, these annotations are really valuable and really important. And to give you an example of why, let's say that I'm coming in to something that's broken, and maybe let's look at this one. So maybe I'm looking at an application here, and there's an issue with it, and I need to understand why. One of the first things I can do is I click on the image, and it will give me a full report of where that image came from. So this one actually has a UI testing associated with it from Sauce Labs. So I can actually, it'll take me right into my Sauce Labs account where I can see all the tests that ran. And I can also see the commit SHA that will take me directly into what changed in that build. So I can actually see what changes went into creating that image. And we have examples where you've got, maybe you've got a Jira ticket associated with it, like no, not that one. I thought maybe this one would. No? Let's try this one. These all ran the same flow. Let's look at this one. This one did pass. Okay, so this one has like a security report associated with the image. There's a Blaze Meter report, a Jira ticket associated with it. So all these kinds of things, these are all customizable. We have a bunch of built-in plugins for doing that. Anyway, it's a little off topic. So coming back, that's in essence how the blue-green deployment is going to work. Now, if you would like to do that, if you'd like to replicate this, you can go to the blog post that we have, codefresh.io/Kubernetes tutorial blue-green deploy. You can just Google simplest blue-green deployment, maybe throw Codefresh on there and you'll find it. And then I would encourage you to look at this quick canary demo using Istio and Codefresh, because this, it's just on YouTube. It's a full video, and this doesn't really, I guess you can't quite click on this. So Taryn's going to put this in the chat so you can bookmark it and watch it later. But this shows a much more advanced deployment method, and it uses Istio, which I think is really critical for how you deploy, manage sort of these next generation deployments. So with that, let's jump over and look at some of the questions. So one of the questions that we got is there any way to do blue-green deployments using Helm assets and not direct kube control? Yes, there is. There are a couple of ways to do it. So the way that I would recommend doing it is actually inside of that Istio video. And it will show you how to deal with creating an array of deployments that happen all simultaneously, and it's all built on top of Helm. So when you watch that video, what you'll actually see is that we used Helm to create two stacks, two services, and two deployments at once. That's really just because it's tied with Istio, and so we're dealing with services rather than the deployments. But the principle is the same. So you can actually do this with Helm as well. So I would encourage you to go check out that guide, which would probably be a much more in-depth kind of way to do it. So looking at some of the other questions, do we need to update the service and deployment object after every commit? No, not after every commit. Maybe after every commit to whatever branch you are deploying to. So like if you're deploying to your master branch, I would keep them up to date. But it depends, right? So we do have people that are doing sort of a GitOps, approach, where they have Codefresh generate the YAML and then make the commits back to Git. And in that case, there are certain changes that it makes that you don't necessarily want to update your YAMLs for. So you can set conditionals on those steps so that you don't run it every single time. Now in this case, every time I update my image, I want to update my deployment and my service object because I am doing this blue-green deployment. Now, you could keep the service object the same and just update your deployment, but then you'd be doing a rolling update, not a blue-green update and not a canary update, right? So there's some implications there. Looking at some of these other questions, looks like a lot of people complaining about my voice, sorry. And then there was a question about whether or not this will be recorded. Yes, it is recorded, and we will post it on the blog. We'll actually attach it onto that original blog post as well. So I think, let's see if there are any, oh yeah, there are a few more questions.
Looks like we got one more question, yeah.
Which would you recommend for complex multi-microservice deployments, blue-green with kube control or the Istio-based approach? So I think that for me, my recommendation is to use either a blue-green with hot swap or a canary with Istio. And the reason that I say that is because I think that it's more reliable. And it's just a lot safer to have something that you can interrupt and come back to and roll back to. The thing that I like about canary is when you do a blue-green with a hot swap, you are all in on that change, right? You're saying everybody's going to get this traffic. And so if there's some kind of regression that's caused, if you created some sort of performance issue, then you are going to immediately impact all of your users with it. And so I really recommend doing a canary release because you can say, hey, I only want like 5% of my traffic to get this for like 20 minutes. And then I want to monitor and see what my load levels are like and how it's working. And if it's working as expected, then let's slowly roll it out to everybody. Now that assumes that whatever you're rolling out is comfortable living in that kind of environment. If you're using something like Elasticsearch, don't do a canary release with Elasticsearch because it does not like, it will be very upset at you if you have two different versions of Elasticsearch running at the same time because of the way that the replication works. So that's just an implication of sort of stateful applications. So if you're using stateful applications, blue-green is usually your best option. If it's so if you're doing something like MySQL or something, blue-green is going to be the way that you're going to do it probably. But if you're doing a stateless application, a stateless Kubernetes application, then canary is a much safer option. So hopefully that answers that in a fairly comprehensive way. Would you recommend? This is another question. Would you recommend that the CI orchestration speaks to Kubernetes using kube control or through its REST API? So I think that the best way to do it is through kube control. But let me clarify. Your end engineers, your back-end engineers, your application developers probably shouldn't have kube control installed. They probably shouldn't have that kind of access to your cluster. Now, if your CI system is using kube control, it's totally fine because really what it's doing is it's just providing an easy way to work with that API. And it's really no different than accessing the API directly. There's not an additional security implication of having kube control there. So I think that kube control is probably the best way to do it. And it also helps you deal with like keeping versions intact because you can have like a kube control client version and you can make sure that matches your server version. So there's some advantages, I think, of using kube control over just working with the API directly. Plus, like, there are a bunch of people working with kube control to make it really easy. Whereas if you're developing against the API directly, then you're going to have to take all of that workload on yourself. And I would recommend against that. Now, inside of Codefresh, when you add your Kubernetes cluster and you use our built-in deploy steps, there's a bunch of kube control going on in the background. There are some things that go on that are hitting just the API directly and not going through kube control, which are mostly for like caching reasons. Like if you're working with config maps, there are some implications of using the API directly versus Coop control. But what you really do is with Codefresh is once you've added it, you've really removed the reason that people need to have Coop control installed, because they're going to be able to interact with these Kubernetes objects through the role-based access control that they have on Codefresh. So it's a little bit easier to manage those permissions. And I mean, let's face it, most of your application engineers don't really want to worry that much about Kubernetes. You know, maybe they have Minikube installed on their local machine for their local development process, but they basically want to make it commit and then have things happen and not have to worry too much about it. And a good CI/CD system like Codefresh is going to handle that stuff without having to get the engineers sort of wading through that dirt. So that's good question, very interesting. I think with that, here's a question. Looks like it's a response to that. There is no security when Codefresh or something equivalent use the Coop control. Do you have recommendations for security, or what are the steps taken at Codefresh to make sure it's secure? Yeah, so when you, there are two layers to that. One is the security that you have on your Kubernetes cluster itself. So Kubernetes has role-based access controls. So you can say this, so you can actually say Codefresh can work within this namespace, or it can create objects, but it can't delete them, or whatever. You can set the parameters of that using the role-based access control kind of permission set that's native to Kubernetes. Now, once let's say you've given sort of an admin role to Codefresh, you can then set who has access to actually work with that cluster. So you can say, well, these 3 people can actually work with the cluster directly. These people can't, and all they can do is push changes that these guys can pick up and then deploy. So that creates a separate layer of security and responsibility where these people are responsible for the account, the role that can actually push things and interact with the cluster, and these people can only sort of monitor. And you can actually mix those two things. So you could say, well, I want these people to be able to see the cluster, so I'm going to create a Kubernetes role-based access control, a Kubernetes RBAC that says only monitor, and I'll add that to Codefresh, and then I'll set that team to be able to use that instance, and then I'll set this team to have the full-blown Kubernetes endpoint, admin access, so they can actually push and deploy and roll back and things like that. And one, like just another anecdote on that. This is actually from the same guys that were telling me about the kill pod to deploy method that some of their engineers are really creative. They come up with really creative ways of doing things. But one of the issues they dealt with is when their engineers started writing Kubernetes configuration files, they were like, deployment replica number 100. My app is going to be super popular. I want 100 replicas so I know that it stays up. And the ops team is over there like pulling their hair out. Like, we don't have budget for you to run 100 replicas of your app that just launched and 2 people know about. What are you doing? This kind of model lets you sort of look for and enforce rules and say like, oh, if somebody makes a configuration change, if one of those guys made a configuration change that says they want more than like 3 replicas, we're going to flag this thing and just send it back. And it will just automatically go back to them and say like, too many replicas, get out of here. So it's another reason that I recommend using, auto scaling, but you get into those situations, right? And I'll hear people sometimes say, well, we trust our engineers, we trust our engineers to do the right thing. And I would say that, the best approach is, I think there's a political term that's trust but verify. You want to trust your engineers, but you want to verify and help them along. So you want to have those automated checks that say like, you're not doing anything too crazy. You're not trying to just spike up the replica set. Sometimes people make mistakes, and you want to make sure that your build system, anything that's deployed went through your build system. I'll hear people sometimes argue, well, I want to be able to build locally and then push to production. And I just, no way, do not ever do that. You don't know if the changes are committed. You don't know if their machine has been compromised. You don't know if they're malicious. You don't know if they just added a library that doesn't have you know, the proper licensing or something, now you guys are going to get sued. So you want to use a build system that's going to check for those things. And we have a bunch more videos at Codefresh on how to do security scans and how to do UI checks and all of those kinds of things, so you can really beef all that up. And I would say just my final note would be, go create a free Codefresh account. Go to codefresh.io, hit create account, go create a cluster in GKE. I think we're running a promo right now where you can get up to $500 in GKE credits. Connect your cluster and start playing around, and you'll find that there's a lot there to help you just get up and running and get this stuff going. And then as you sort of transition into the deeper stuff and you're like, oh, well, I really want to do UI testing, security scanning, those kinds of things, there are tons of resources and sort of built-in sort of plugins and things you can use to do that with Selenium or Sauce Labs or Testum or whomever. So we also have whole webinars on dealing with stateful applications. But anyway, with that, thank you very much. Appreciate you joining us today. Hopefully that was helpful and enlightening. If it was, let me know on Twitter. Say, good job at today was awesome. We really enjoyed it. Here's the link that I'm promoting to my friends, and I'll like that and appreciate it and make more videos like this. I'll answer one more question before signing off. Sean asks, I'm new to Codefresh. Does it support deploys to private cloud? Yes, it does. It supports deployment to private cloud and on-prem cloud. So on-prem cloud you can deploy anywhere with Codefresh. If that's a you know, bare metal Kubernetes cluster that you have on-prem, or if that's a virtual private cloud through Amazon or Google Cloud, we support all those modes of operation. So if you have any questions on our site, there's a chat box bottom right of every page you can click on and ask questions, and you'll get in touch with our support, and we're happy to help you out in case you don't find it in the documentation or whatever, but there's documentation on that. All right, well, thanks everybody. You have a great day.